Hello everyone. Let's work through this 80-20 example. That way you can see how I actually work through it, because sometimes when you're looking at the pages I've created, yeah, there's a bunch of pictures, but it's a lot easier to see when you're walked straight through it. So let's say we're given, well, one thing, let's just talk about 80-20. I like 80-20 just because it's kind of like the indirector set for adults. We, you can construct frames. A lot of people I've seen, like a lot of the new do-it-yourself DIY type 3D printers, they'll use a lot of the extruded aluminum, configurations like A20 does. A20 is not the only company that does these type of profiles, but the one reason I like A20 is because their website is great, and two, they provide a ton of CAD and especially SolidWorks. You can download an entire SolidWorks suite of all of their components. They're already, the parts are built in SolidWorks, and some of the dimensions are already there, and you have a lot of the profiles. So if you want to make a exact length, let's say like this 60, you can just drop and drag the profile of which one you want into SolidWorks and then extrude to whatever length you want. So with this, a lot of times you can just look at the pictures, you zoom in, and you can probably figure out, the more you look at A20 and what they have, you can figure out which profile they're using. And especially if you have, they have ones that are done in US inch format, and they have ones that are done in metric. This one, 1515 LS, we're gonna, I give you that. That way, you don't have to do so much research to figure out what it is. But the other component is when you find like there's the 15 series and 10 series and a few other series. You'll notice with like the 15 series, they have specific brackets that are made for 15 series, so they're a specific width. And that makes it easier for you to pick out which one you need. So first, well, let me go back to that picture real quick. Like I said, it's a 1515. Oops. Yeah, 1515 LS. LS is the lightweight one. It means it has much cutouts. So if you go just straight to the A20.net, you'll pull up their main page. A lot of these websites, I've already signed in. Most of these websites, if you want to use their like CAD program or whatever CAD stuff they have, they want you to set up a account. Accounts are free, so like I say, feel free. Pretty much almost every single CAD site I've gone to that is online, wants you to create an account, and usually it's just you give them a username and your email, and then make your own password up. That gets you access to all the information that they have. So I've already logged in. Let's see, did I log in already? Yep, I'm already logged in on my account. But on this main page here, let's go to A20 bookshelf. Now, technically, you could request a hard copy, which if you look at the upper right corner, yeah, I always keep hard copies of a lot of things just because it's simply it's faster just to scroll through them real quick. But one thing that A20 has done in literally, when I was working back at Lockheed, I used to actually I've designed a few things using A20 components, and back then they had a lot less CAD. They had all of it was two-dimensional profiles, which was perfect. That way I don't have to actually create the profile and then just extrude. They've gotten a lot better with their CAD files. Now you can actually download parts and a little bit of everything pretty much everything they have online. But I like the interactive catalog because you just select this and it's an interactive catalog online. It gives you all the stuff that they have. Right here's the quick reference catalog, and actually you select where you want to go. We got the 1515 LS, so we're looking at T-slide profiles. I'm going to go here, page 76, click on that, and we are brought to their T-slide profiles. Now, let's see, do I have a picture? These are all the ones. So, if you look at the cross-sectional, actually, let me fast forward to. Do I have a picture? No. All right. Well, from here we can actually just search for what we're looking for, and I'm looking for the 1515. This is a 10 series, so it's a 1 inch by 1 inch. So 15. What's 15 going to be? We'll find out. Scroll through. Still in the 10 series. Oh, 1020. And it's like 10s, 1030s. It's like a triple stack. 1020s, 2 by 2, or 2040s, 20. Now we're in the 15. Oh, look, 15. Now we found our 15 series, which are 1.5 by 1.5 inch. If I were to draw a square rectangle, that's pretty much the size is. So 1515 ULS, ultra lightweight. They have a lot of cutouts. 1515 LS, right here. Fractional 1.5 by 1.5. It's got some cutouts. It makes it light. Yeah, the L, I guess, light, fractional. So, there's two ways to actually use this program. This just gives us the information and what we need, 1.5 by 1.5. Now, how do I make my components out of it? Now, if we go back to our images here, all right, and we did our calculations, and I found the profile that I want. There's two methods, and I'm going to show you both ways, just to make it quick and easy. All right, first calculate. Well, we know the back one is 60, so if I zoom in and look at this picture, so I need one that's length is 60, and then I need this horizontal. We know it's 24 inches wide, so if we know 1.5, 1.5, do your math. So we need a 21 inch length, and I made this one simple. Technically, 24 also inches this way, so this one's also going to be 21 inches. And notice how I made, if you go back to that one picture, 24 inches from outside to outside. That means these ones are also going to be 21 inches. So pretty much there's only going to be two components here. You can have a 60-inch long length, and all the short ones, horizontals and verticals, and all these components in here, they're all going to be 21. So you got only two I need to make. Yeah, if you zoom in too, let's might as well go over this section while we're at it too, just so you can see where to go. If I go to the little angle adapters, just by looking at the picture, okay, we're having the 15 series. Let me go back to the first couple of pages right here. All right, fastener methods, internal, external. We're gonna go external, and then let me just go through these, and see what choices do we have. Bunch of brackets. Brackets are cool. Plates. There's so many different ways you can fasten. Here we go. Oh, now we got to what looks like where we need to be. Okay, here's the first section. Let's see if I can zoom in a little bit. Oops. All right, 10 series and 25. No. Oh, look over here. I see 15 series, and that one looks a lot like that image. And that's how I found the 15 series, because 15 series goes with the 15 series extrusions. So this is where our bracket, we'll find the bracket that we need. So let's go over the first method. If I go back to the product catalog, and one thing, if you go to your helpful tools, one thing I found about this, you hover over this and you're like, hey, why does it disappear every time I go down? Well, you just have to go down, oops, quick. Oops, let's see. There. Go to the CAD library. And notice, we have, well, 3D Central. Hey, SolidWorks actually, at 3D Central, or 3D Content Central, has pretty much all the A20 components in there that you need. I like going just to CAD Direct right here. This is what the A20 has. And you can select, well, if you're going to work with A20, I suggest right here. Open up, the free, account with just a username, your email and password, and then you can select this portion right here and download an entire SolidWorks dynamic library. This was updated, a couple of years ago in July of 2018, end of July. I've already actually downloaded it, and this is what it comes with. It comes with pretty much everything: structural shapes, weldments. Like here is we're going for fractional, and we're in the 15 series, and we're going 1515 LS. Let me see, here's 1515 LS right here. So the easiest way, let me open up SolidWorks. Oops. And 1515 LS. Yeah. Just drag it in. Create yourself a new part. Wait for it to open up. And voila, you have your profile. Now, the profile sketch, we need two of them, 60 inches and 21. So, one thing always verify is I notice a lot of times, you know, some of you all, when you start your part, we know that the 1515 LS profile is in inch format. It's not the metric, so make sure that we are in the inch format. You know, when you this imports, usually it picks up what it was originally done in, but if it doesn't, always just verify. But I've noticed sometimes, you know, sometimes you get some errors where it comes in the wrong format. So make sure you're in your inch format, and then it's as simple as highlight your sketch, and then let's make our part. Let me see, I need a 21 inch. Here is a 21 inch long. And then always make sure you save. Let's see, I'm going to go call this A20 example. 1515 LS by 21 inches. Yeah, it was an old version. Sure, save it as a new one. It's our 2019. Now, I have that one. Let's do another one. Or I can actually, here's an idea. Since it's already in there, I've got the 21 inch already saved. File, now let me do a save as. I need a 60 inch. It's just saving as a different format. And then I can go back into here and change the parameter to 60 inches. Now I should have two separate. Got my 21 inch and I've got my 60 inch. So that is the first method of making it. If you were to download back to, download the entire SolidWorks dynamic library, or you could actually just pick exactly which format you want. See, SolidWorks extensions here, they also got 2D DXF, IPT, SKP, and there's other ways you can download more stuff. So you could just download it, say, the 15 series parts or the profiles. Or, like I say, if you're going to use this a lot, it's fun, and you have enough space on it, because it's actually about 5 gigabytes worth of data. It's going to take up a lot of room on your hard drive if you have a small hard drive, but pretty much everybody nowadays got terabytes of storage. So having a extra 5 gigs, makes it nice. You have everything there. So that's the first method. Now let's go for the other second method of making this. Let me go back to first page. I'm going for my T-slide profile. I'm at the 1010. Let me go to the 1515 LS. So now here is the secondary method, which makes it a lot easier too. 1515 LS, which I need. Oops. You just select the 1515 LS, and it will bring up the part page. Now this makes it really easy. If you thought the other way was difficult, both ways I think are just as easy. I kind of like importing the 2D version, on a sketch plane, because then I can just extrude my own length. This one, I guess they've gotten a lot easier for people to specify exactly what they want. So people, I guess, that are not the most CAD centric, you can be using SketchUp or something like that and download a different format other than SolidWorks, something that you can open up in SketchUp and import these files and work with them. So this would be I guess, the really easy way. You say what length you want. Let's say I want a 21-inch length. You could add machine services, but no, I don't want that. I want CAD file. Oops, 21-inch. Generate. And since I'm already signed in to this account, whatever, it won't work if you don't have an account. So you make yourself an account. Here I have. Oops. There's my 21-inch length one. I just say CAD download. And if you want a different format, see this little button right here. Right now I have it in SolidWorks. It's 2008, I believe. I need my glasses. Or 2006. It's an older version, but it doesn't really matter because it'll update. Once you import it, you can update it. But if you wanted something, if we weren't working in SolidWorks, or when you first do this, it might not be SolidWorks. You can say add formats, and when you say add formats, oops. My bad. It's having issues. Wait, I need my glasses. You have selected too many formats. Please remove. Oh. Okay, you can only select one at a time. Never mind. But here is where you got many different CAD formats. So we've talked about this, I guess, previously in the previous section, that SolidWorks is a good program, but there are so many other programs out there too. So once you learn one, you can pretty much pick up any other one. Let me go back to SolidWorks. Here's the latest version. So you can only add in one format. Now I realize why that didn't work. And start generation. Now it has generated my 21-inch. And actually, it pops up right in my downloads automatically. So this is in my downloads. I could, let me see, I'm going to actually drop and drag this into where I was storing the ones I just created. Wait. That's not very small. Yeah, it is. Alright. If I double click on it, feature recognition, because it is an older version. There we go. Same thing. So that is the second way of doing it, which makes it very easy. So now you got two different methods of using the 8020, either creating the part yourself or creating the extrusion via the website and having them create the length for you. All right, now one thing I noticed also when I'm going back, I'm just using the ones I created from the 2D profile. They're saved as oops, so they're saved as actual feature parts in SolidWorks. I want to save these as just actually parts. So I have my 21-inch, and let me go to my 60-inch file, save as part. Now, one thing also, okay, I've got technically the two pieces I need. Well, one thing also, we could look at remember the 4302 bracket. You know, if we looked at that, we saw that in the page. We got two methods. One, we can go back into fastening methods. Okay, we're going to actually go back and forth now. But okay, let's figure out how I want to make this. When you do an assembly, remember you could, there's many ways to do your assembly. You can import one part at a time and then import the next part. So I can import like one long 60-inch extrusion, then put another one of the 21 inches, and then another 21, and then put this one, and then redo the same for the bottom, and then just construct it one part at a time. Or what I like to do is technically just import one part and then import the, let's say, well, right here I got three parts. I've got two of the extrusions, 60-inch and 21, and then I have the angle. I like to import just one of each one and then start doing mirrors and patterns. Since this is it's very symmetrical, easy to make. One thing I look at also as I construct, I'm going to need reference points, so reference geometry, maybe central axes or central planes to mirror from. So I'm going to go back in and just add some extra features, like on the 21 inch. Seems like because I got two sides, if I were to construct one and add all these, I can just mirror. The other thing about working with A20, it's symmetrical. Technically, the part doesn't matter if I look at it, vertically, rotate 90 degrees, it's the same. Rotate again 90 degrees, it's the same. Or I flip them around, it's the same. It's a very symmetrical part. You can literally draw 1/4 of it. Chop out. If you look at the profile, chop out like an upper right corner, upper left corner, lower right, lower left. Do 1/4 of it, and then do a circular array. 4 times, you'd have the same part. That's what the nature of this type of extrusions makes it very symmetrical. Makes it easy to work with when you're creating the assemblies. So what I do is I'm going to do it the way I kind of stated in the pages. You can do it whichever way is easier for you. But the way I'm going to do it is make one and then bring in one long one, bring in one short one, and then actually create copies of it within it. All right, going back to my parts. Let me open the window. I want a 21 inch. So I can already see I'm going to be doing a lot of like mirrors and stuff like that. So let me insert reference geometry. I want to do a plane right in the middle. What I'm going to do is going to select this one, this plane, this one. I have one right in the middle. This one, mid-plane, mid-plane. I have reference geometry right in the middle, so if I'm going to add long pieces on this side, I can actually mirror right across. And let me see. Do I need to add any more? I can always add in more as I build. I think that's one of the key ones right now that I will need. So let's go now. Let's start building. I'm going to create an assembly. And one thing I noticed on that. Let me insert the 60-inch one real quick. And I'll build off of that. Make sure I'm in IPS. I just noticed when I was over here, IPS. Okay, they're all IPS. This one, for some reason, came in millimeters. 54302. Okay, let's save our assembly before we even start. A20 example. I'll make this A20 frame assembly. Now, let's insert a component. Since I have the ones open already, I need a 21 inch. Yeah. Alright. What I want to do, I want to rotate that. Move component, rotate. You could do, there's many ways. So, what I'm going to do, I'm going to put one on the end. Doesn't have to be perfect. Because, let's see, X, Y. Good enough. Close enough. Okay, let's do mate. I don't want. The good thing about, I guess you could say the shapes, if you'll notice, oddly, not really oddly, but when they design these in the profiles for CAD, they made actually the tops of them flat. It took me a while. Look at this. Oops. Because if you look at your in reality, there's a slight angle on the top. That way, when you a lot of these, what they call these T-nuts, you slip these little nuts in these channels down here, and then when things attach, it actually pulls these components up and makes it flat. It's like adding a tension. You're getting a preload when you tighten up things that are attached to the top of this. Helps it stay in place, helps it stay fit together. So I guess to make things easier, they just made the tops and the sides parallel instead of slightly angled in, which makes it easier to actually align everything. So, what I'm going to do, I want to go, I'm going to actually move it out a little bit. Let's see, this one, let me just move it slightly up. So now, I want this face and this face to be aligned. Now the top's aligned, that part's aligned. Oops, right, left. So you can see that. Now, technically you don't have to do all these extra moves I'm doing. I'm just kind of making it so it seems easier for me. Now, I'm just going to mate this face to that face. So, oops. That face to this one. Now, this is pretty much fully constrained to this very corner. Top, this face, basically three faces, three orthogonal faces are all aligned. Now, if I want the 21 inch, or actually I can put one on the other end. So, here's an easier way. Now I can open up, simultaneously you can open up, let's say 60 inches. Remember how we, on the 21 inch, I did the plane in the middle? Well, I want to put the plane in the middle of this one too. So, reference geometry plane. Select that surface. Select this surface. And we've got midplane. Now, Control S, save it. Let's go back to my frame. Yes, it needs to automatically update because we did something new here. Now if I want, I can do view, show hide, planes. Now, this is where I want one on the other end. I'm just going to do a mirror. Select mirror plane. Because remember, if you look at this, it's symmetrical. So it doesn't matter if I have the upper facing, doesn't matter which direction you put it. Any one of these four sides are all the same. So, and around the center, everything is very symmetrical. So that's what makes it fun and easy. Now, here it becomes a little more tricky. Now I want to do a, let's see, 21 inch. If we go back to our picture, I want to do this upper one right here, which is 24 inches away. Of course, it's not allowing me to look at that. Yeah, much easier looking at this picture again. So 24 to the outside. So it's the same. We're going to have 24, 24. There's going to be 21 inches in between. So if I can get this to 24 inches on the outside, let's do a linear component pattern. Direction 1, let me go along this. I need 2 of them. I want the reverse direction. Let's see, 21. This always takes me a couple times to figure out. Let me do this real quick. Evaluate. How far is it from this plane to this plane? Normal 22.5. So I need 22.5, 23.5, 24. So I need 1.5 more inches. So originally 21, so I need 22.5. To be what we need. Let's see. 24 inches, outside to outside. Alrighty. Now, notice how I added in this plane. Well, if I want to get one to the other side, I need my 60 inch. Let's go back to our assembly and let's do a mirror components. Here across the center. Bingo. So here'd be considered the top. Now, I need vertical components. Now I remember I want to add in a feature to this. Let me see. Yeah, for right now I'll do it on, let me save while we're doing this. I'll do it on the 60 inch. I want to add just an axis in the middle. Insert reference geometry, axis, or axes. I should go all the way down the center. Now, hit Control S, save. Go to 820 frame. Need to update, yes. Alright. Now I want to view. Oops. Show hide. Axes. The reason why I'm doing this is because I need the verticals. And remember how we did our calculations? We calculated 24 outer dimension, 24 outer dimension, 24 outer dimension. So all these are going to be 21, 21. So if I can just take this one and actually do a linear pattern, and do it 90 degrees. From that, I should get the vertical. I can do the same thing with the same one on the other side, 90 degrees. Same one here, 90 degrees, 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 and then copy the entire upper set all the way down, and then I just have to do, I can copy these ones down the middle, and I just have two more I gotta fill in, which I could use, the center one. So you'll see. So let's go back to our original. I want a circular pattern. Now I got the component, I want the axes, and I want to, how about 90 degrees? Bingo. Now, let me do it again just for the other side. Circular component pattern. I want this axis I made. 15. I want 90 degrees. Now, to make this a little simpler, now I got these two circular patterns that I've done. I could do another mirror just to get the other side. And these two circular patterns, I can do a linear pattern. .5 inches. See how quickly everything comes together when you want to construct using just the two pieces and then just using a bunch of patterns. Now I want to, let me take this whole upper portion. I want to here components, local pattern. And this I could do, let me see, I could do a linear straight down. Let's do a linear. I could do either a linear or I could do a mirror. Let's do a linear pattern straight down. Reverse direction, 22.5. I've got the bottom frame. Now I'm going to want these two, which is, let's see, it's not that one, it's this one and this one. So I got these two, and what I want to do is a linear pattern straight down, and I want them to be in the middle, opposite, and it's not going to be 22.5. So 22.5 divided by 2 should be right in the middle, right? But let's see, is that correct? That doesn't look correct. Let me see, 22.5, 21. Divided by 2, because I want to go in the center of this. Now let's just verify real quick. Evaluate, measure. Let's go to the top. Okay. Measure. Oops. Oh. Not a good way to measure. Let me try this one more time. Oh, normal distance. All right. Measured, I had a 10.5 inch down here and a 9 inch up here, so I have a 1.5 inch difference. So I need a 0.75 inch, so 0.75 inch difference come back down for that pattern. So let me go back to Edit Feature 10.5, 11.25. Looking good. Now, once again, these are just all the components just for what the actual frame portion is, not taking into account the angles. Now I need, say the same thing on this. I got an idea. We're going to take this pattern. I want to evaluate more. I can take either one. I'm going to take this one and let me do a circular pattern. And I'm going to pick the, do I have an axis here? Let's see. No, I don't. Oops. So, escape. What I need to do is go back to my 21 inch. Now I realize, oh, I need an axis on this one also. Axis right down the center. Save it. Go back to my frame. Update. Now, this one I'm going to do a circular pattern. Pick the central axis of this one. (270 degrees). Got that side. Now I can re-pick the same one. Circular component pattern. Oh, enter the pattern. (270) also on that one. Now we've constructed the frame, all from the original 2 components, just by doing patterns, linear patterns, circular patterns, and mirroring. Because it's a symmetrical part, you can do that. All right, back to the corner angle bracket 4302. I think I actually skipped over this earlier. Just the 2 methods actually to find that part. One is if you actually download the dynamic library. You go to your fastening methods, external fasteners, corner brackets. You just go down to 4302. 4303, no, 4302 right here. You got your 4302. There it is, 4302. That, or you could, so you go into the CAD department over here, but we can go back. Let me just go back to our catalog and go to the fasteners, external fasteners, and skip forward to the 4302. Oops, passed right up. Right here is our 4302. Can I zoom in a little bit? But if you select on the 4302, 15 series, 4302, just like the extrusions, come here, go to your CAD files, generate, and it'll generate your CAD file. And you get the CAD file. Oops. And hit your CAD download, generate CAD, and bingo, pops up for you. That's the second way. So now you got both ways of getting the 4302 bracket, and we'll use that later. All right, let's work on the 4302 bracket so I can bring it in. In order for me to line it, I'm just going to add a plane, reference geometry, right in the middle. I found this to work very well. And let's see, tools, reference geometry. I'm going to add some axes. And save it. Let me get back to my frame assembly. Now I'm going to want to insert the 4302 bracket. Sorry if you guys hear my children in the background. They're playing outside and I have the window open. Alright, I want to rotate this. 4302. I say symmetrical part, so it doesn't really matter which way I do it. Alright, good enough, close enough. I'm going to do things. I want to mate this surface to this flat surface there. There's one. Now let me align this with the center. So I can do this plane with, let me do it with the axes. Did that work? We'll find out. And then if I do this flat surface with this one, and that seems to get it all perfectly aligned. So now I'm going to use the same methodology that we did with constructing the entire frame out of just mirrors and linear patterns and circular patterns, and see if I can just populate everything. First, let me do a linear. Actually, let me do a mirror because I'm going to do a mirror right down the middle. Let me get it right on the other side because it's also symmetrical. So if I do airplane, there we go on that side. Let me get now a linear pattern. Oops. Of this one right along, oops, the other direction, and 2.5. Start to memorize the numbers of all the patterns. Now let's take that one and the two I just created, and let me mirror it around the center. Mirror components. Just pick one of these planes in the middle. That should give me all of them. Like I say, this is all part of looking at the original picture. Let's see if I can go back. And looking where they're all placed. So they're on the insides and the sides, and they're all underneath. They're not on top. So, and the only spot that's different, they get 2, 2, 2, 2, pretty much 2 on all of them except for right here. I got 1 on each side, 3. So 1, 2, 3, and up here 1, 2, 3, 1, 2, 3. But otherwise, I got 1, 2, 1, 2, 1, 2, 1, 2. So this I can take actually now all these, mirror them straight down to the bottom. But you know what? Before I do that, let me complete the entire top. And that way, alright, how about this one right here? Let me do a rotate. So do a circular component. Let me do it off of 270 degrees. This one, same thing. Circular component off of the center, 270 degrees. Now, let's see. I wonder if this will work. Let me try this. We got these two circular patterns. I'm going to want to do it on this side. Can I mirror it off of that one? Let's find out. Oh, I want mirror pattern. I want circular. Or I want mirror, actually. If I were to pick that. And it came on the inside. Good. Now, these are the only two that I need. Oops. That one, and is it this one? Okay, that one and this one. Alright, watch this. Let's do another mirror off of. I have the central point. Bingo. And then now I just need one more right there, and actually I could take the original two that one and what's this one? So that one and this one. And let's mirror that one. Across the central area. Oops, that worked. Oh, duh. Undo. I can't undo that. I have two stacked on top of each other now. I don't want that. I picked the wrong ones. Delete those two mirrors. I wanted these ones. What am I trying to do? So this one and this one. Select the entire bracket. Wait, oops. Gosh, I'm selecting the wrong one again. Okay, this one and this one. Gosh, it's so hard selecting things sometimes. Now, mirror. Now I've got the entire brackets on the upper one. Let me take all the brackets. My children acting crazy. Let's go through and select all of my 4302s that are on the upper surface and mirror those all the way down the bottom, and then I can just concentrate on these ones right here. So let's go 4302. Just go down and find all my 4302s. I believe that's all of them. Oh, still got actually some more I got to do here. Never mind, let me mirror these ones. 1 and 2. Do a, well, let me see, don't want to do a circle, I'm going to do a mirror pattern, and I'm going to pick the central plane. There we go. Alright, I got all the 4302 brackets on the upper portion done. I'm just going to mirror those down the bottom, picking a central area. There we go. Now I just have to concentrate on the last section, which is right here. So technically I need this and this, these two copied down and those two copied down. So let's see if I can select the ones. 1, 1, 2, 3, 4, 5, 6, 7, and 8. Now 1, 2, 3, 4, 5, 6. Okay, where's the last? No, like that. Oh, come on. Sorry about that. Let me, gosh, oh, I need to somehow figure out how I'm going to do this. Okay, 1. You know what? I'm going to do it a couple at a time. Makes it a little more easy. I try to select them all simultaneously. 1, 2, 3, 4. All right, let me do this real quick. Okay, that's not even the direction right here. One 1.25 now. $11.25, if I remember correctly. So 11.25 inches down, and we're set now. I just gotta select these 4. So 1, 2, 3, 4. It's basically all these 4 of these ones. Four. Let's see if I can do this again. Linear. 1.25, and there we go. Let me clean up everything by saving first. Always save. View, hide all types. And it looks like I have successfully constructed this assembly. So that is how you do it with, let's just see if I can clean this up a little bit, using all mirrors, linear and circular patterns. If you do it correctly, this is what your tree will look like. 3 parts, 60-inch extrusion, 21-inch extrusion, and the 4302 bracket. And just by linear and circular patterns, oops, I'm missing one. Aha. See, always double check. Hey, how did I miss that one? Where is this guy? Well, you know what? Let me just make it easy. I'm going to do one more mirror. Now, I'll double check, make sure I've got everything. 1, 2, 1, 2. So this is how you build a A20 frame. Now we could take it one step further. A20 does allow you, it has all the fasteners. I don't know if you remember the page. Let's see if I can bring back that page. Fasteners down here. It gives you the optional fasteners, and you can actually have suggested hardware and download those simultaneously also. Fits right into the slots. I think in the future I'll show you how to do that, and we'll go through an example of how to put the actual fasteners in there also, and that way we can do a full build from, if you actually order all the parts, you can physically build it. So that is the example, and it's extremely long. Sorry about that, but it just goes to show that you can build it more than one way too. Like I say, I did everything with mirrors and linear patterns and circular patterns. You could just individually bring in every component, but you might want to add a few more reference geometries, maybe some points, could be more planes, to get everything to align perfectly. You could even put, if you knew the exact location of the A20, like the 21-inch members, you could put, the center lines, the axes, and then put individual points at the exact locations you want those to be at, and align them that way. There's always more than one way of doing it.